Okay, good afternoon, good morning, whatever time you're looking at this. Um, what we're going to do today is perimeter and area. We're going to talk about irregular shapes, which is something like this. And then we're also going to talk about something that's plotted on a grid. Okay, so we can classify and find the perimeter and area of this. Okay, so estimate the area of an irregular shape. Okay, I don't want to spend a lot of time on this, but basically what you're going to do is you can break this into composite figures. Okay, use the highlighter here just to, so right in here and down to here, it's basically a rectangle. Okay, so you have 5 by, um, let's see, 5 by 14 across. So you have 70 square units in there. And then you can kind of use that same idea in other spots. Like you can make a rectangle, say right in here. Get my highlighter back again. So from here over to here, another rectangle. Get the area of that guy, and so forth and so on, until you have, uh, you know, most of the figure. So right in here, you have a rectangle right in here, and maybe count this guy as well and this guy as well. So then, roughly, then what you're doing is at the end of the day, you're starting to look at blocks that aren't fully shaded, okay? And typically you're going to count those as halves or wholes or something, something like that. Or you're just going to use your best visual estimate. So if I work up in this in the top middle of the figure, so right in here, if I was estimating the the uh, the units in these not fully shaded blocks right here, I'd say that looks like about a fourth out of that one. That looks like about a fourth out of this guy. So those two combine to be a one full, okay? Like that would flow in there. Okay, so then over here, this looks to be about a half, so that's one, a little bit less than half, a little bit less than half, and that would fill in the rest of that one. So that's maybe one and another one there. So that's kind of nutshell, that's how you do that. I mean, there's not much more to it to say than that. When I went ahead and went through this figure, I got an estimate of 144 square units. Okay, so check that with your work, and that's about what you should get for this figure. Okay, but irregular shapes, you find all composites of all the ones that are shaded, and then take care of the rest of it from there. Okay, let's go ahead and look at perimeter and area of this guy. We've got a triangle here, probably, because there's 3 points. Yep, so it's a triangle. So -5, -3. Let's plot the point. 1, 2, 3, 4, 5, -3. Okay, and 3, 4, 3, 2, 3, 4, plot the point. And over here quickly, 7 and -3. Okay, all right, so we've got a triangle there. We want to classify it, and we want to find the perimeter and area. Okay, so slopes and distances are what we need here to get this done. Okay, we need to find slope and distances. These are all things we know how to do. So this is a nice little review here. So from, let's put chord A, B, and C here. From A to B, well, let's find its distance. All right, when I travel through here, I went uh, just using the coordinates, I can say the change in my x was 8. So the change in x was 8. The change in y from um, from negative from -3 to +4 was a change of 7. And I don't care whether it's positive or negative because I'm squaring these numbers. And I get a grand total there of the square root of 113. So that's the distance from A to B. And I know that that's between 10 and 11, but I don't really, care so much about exactly what it is right now. So now, um, for let's go with B to C. All right, B to C. I need to get that distance. And that distance turns out to be um, square root of 4 squared plus square root of 7 equals square root of 65. So that's this side right here. Okay. Okay. Now, quickly across the bottom here, no math needs to be done there because, or extensive math, from -5 to 7 is 12. So this is 12 units across right there. All right. So now I can quickly classify that as scalene because none of those are the same. And I can probably look at the slopes real quick. So the slope of this guy from A to B is, again, my change in y was change in y was 7. Change in x was 8. So it's a positive slope line. So that slope is 7/8. This guy over here from B to C was turns out to be -7/4, right? I'll use a different highlighter here just to demonstrate this one at least, and say, okay, from B to C, I went down 7 and to the right 4. So -7 and +4. So that's your slope there. All right. So those are definitely not negative reciprocals. So that's definitely not a right angle, and I could figure out whether it's probably it looks like it's less than 90 degrees, but we could double check that later. But we'll just call that a scalene triangle for now. Okay. The perimeter, I just need to add up my three sides. So the square root of 113 plus the square root of 65 plus the 12, and you can just pound those in your calculators as decimals, and you get 30.7 units, right? The distance around, not square units, it's just units. And for the area, 1/2 times the base, which is 12, and the height, we highlighted that green line there. See how many units was that? Um, should have been 1, 2, 3, 4, 5, 6, 7. Yes, it is. Times 7, and you put that in your calculator and you get 42 square units. Or just multiply it in your head. Either way. All right. So that's the idea for that. All right. Let's try a four-sided or four-sided figure. So here A, B, C, D has went ahead and pre-plotted this thing for us. So we're all set to go with this guy. And we can see quickly that AB, the distance across there, if I just count the blocks, I have 11 from there to there. And D to C along the bottom here, again, I have 11 from there to there. So those are definitely the same distance. Let's see, are they parallel? Well, the slopes of both of them are 0. So right away I can say I have a parallelogram ABCD because I have one set of lines that are both parallel and congruent. Okay, so it's classified. Now I need a couple more distances here from D to A. This distance here is, let's just call that AD or DA, doesn't matter. Change in Y's is 6 squared plus the change in X's, which is 2 squared. So the square root of 40. And over here, as I suspect in B and C, I get the same thing. It has to be, right? Because it's a parallelogram, so I shouldn't even have to really figure that, but you can double check your plotting and whatnot by doing that. So square root of 40, square root of 40. I have uh, all that I need to do perimeter, and for area, all I need to do to kind of touch this up is say, okay, from here to here, the green line there, what's that distance? And you just count the blocks and go 1, 2, 3, 4, 5, 6. So the height of the figure is 6. So now I got everything I need to do perimeter and area. For the perimeter, I get square root of 40 plus square root of 40 plus 11, so plus 22. And I get, that turns out to be 34.6 units. And for the area, base times height. So I get the base is 11, the height is 6, so 66 square units. Okay, so basically at the end of the day here, what can we do? We can plot a figure on a coordinate grid and find its area and perimeter, and classify it. And also with irregular shapes, we can basically make an estimate as to the area of a figure like that. Okay? Thank you very much. Hope you're having a great day, and we will talk to you soon. Bye-bye.